Hello everybody, so this is our last episode about cross-platform object detection, and in this video we are going to integrate our object detector class into an iOS application. Now this video is not about building an iOS application, but just about how to integrate our C++ object detector into an application using Tensorflow Lite C API. So let's get started. The first thing that we need, just like we did in Windows and in Android, we need the TensorFlow Lite C libraries. So you can head over to my repository, the tflite dist repository, and download the tflite dist zip file. Then just extract this zip file anywhere on your hard drive. I already did this under my project, tflite dist. And what we have the header files under include, and under libs, we have the library, we have the iOS folder under which we have the TensorFlow Lite C framework. So this is one thing that we need. And the other thing that we need is OpenCV. Now, this is our project, the tflite Crossplatform, and I already created an iOS folder with our application. So in order to get the OpenCV library for our project, we are just going to use the OpenCV pod. So I'm just initializing a pod for my project, and then I'll edit the pod file and add the OpenCV pod, and the version that I'm going to use is 4.1.0. And then pod install will install OpenCV for our project. Okay, now let's open the project, our project in Xcode. Okay, so this is our project. We have two view controllers. We have the main screen, which is a single object detection button. Tapping on the button will open our object detection view controller. This is our object detection view controller. Basically, it's a single view into which we are going to display the camera feed. So this is what most of the code here is doing, is just opening the camera. We are verified that we have permissions. Then we create a capture session to capture the camera. And we are creating here the preview layer, so we can see the camera frames. And this capture output, this is the function that is going to process the camera frames. So the camera is going to call this method every time it has a new frame for us that is ready to process. And here we are just going to process the frame. We are going to call our detector. This is the cv-detect method. And we are going to display the results on the screen. Now, in order to draw the detections on the screen, I created this detection canvas class. It's just a UI view. You give it the detections, and it's just looping. It just loop over all the detections and draw rectangles for the detections, and then also print the label of the detected object. So this is our application, and now we are going to see how we actually integrate TensorFlow Lite and how we integrate our object detector. So for that, we are going to, the first thing that we want is to embed our model, our TensorFlow Lite model, into the application. So we're going to our application, we select add files to the app, and then we are just going to select the models. And we are going to select the models folders. So it's under tflite Crossplatform. This is our project, and this is the models, and add. So now we have our models part of the project, and this is going to get embedded into our application binary. And the next thing is we want to start add some native code. So let's create a new group here. Let's call it native. And under native, let's add a new C++ file. We'll call this file CV. Also create a header file. Okay. And we'll place it under the native. And now Xcode asks us if we want to create a bridging header file. So this bridging is what's going to bridge between Swift and our C++ or Objective-C code. So let's create this file as well. So we have here our CV C++ and header files. Now in this code, in this file, I will want to write a Objective-C code. So I'm going to change the extension here from CPP to MM and from HPP to H. And in our bridge, in our bridge file, we are just going to import cv.h. That's it. So let's delete all this. And let's bring, let's write some code here. So our CV file, we are just going to define an object, a CV object. And this is the object. Sorry, I'll just copy the code. So this is going to be our object. Our object is going to have two methods: a init detector, which is going to create the object detector, and a detect method that receive a sample buffer from the camera and return array with the detection result. So this CV object is what we are going to expose to the Swift side, or to the Swift side of our application. Now, before we are going to implement this object, we do need to bring in our object detector itself. So again, under native, add files to the app. And now again, let's go to my project, TF Lite Crossplatform, object detection. And this is the object detector, selecting two files. And this is going to add the object detector to our application. Now, again, this is the same object detector that we used on Android and on Windows. We just bring the files in so we can compile them. We already get an error that this header file is not found, which makes sense because we didn't set up our application to with the correct search path for the header files. We'll do that later. So now let's go to our, let's paste in the implementation of our CV class. And it's fairly simple, nothing too special about it. So I'll copy the code to save some time. And basically what we do here, we import some OpenCV headers, then we import our CV H file, where we define the interface that we want to implement, and we import our object detector. Now, just like in Android, where we cannot create an instance of object detector and in the native world and pass this detector to Kotlin or to the Swift part of our application. So in Android, what we did, we created a detector in the native world, and we just passed an integer, which is the address to the instance of this detector. What we are going to do here, we are going to create a we are going to create a single object detector that is going to live here in the native world. It's going to be static. So this is how we are going to do it here. Obviously, you can think about different ways that you can do this. I'm not an iOS developer, so I just chose the most simple solution. And in the init detector, we need to create an instance of our object detector. Now, if you remember, the object detector, it needs to get the byte array, which is the TensorFlow Lite model and the size of the model. So we embed the model here inside our application as an embedded resource. So what I'm doing here, what we are doing here, we are basically just reading the bytes of this file from the application bundle. So OD model, it's the name of the file, and the extension is tflite. And here we are just getting reading the data. If there is no data, maybe you want to throw an exception here, or I don't know. But in case everything is successful, so we get the size of this byte array, and we just convert the bytes to a byte array. We take the bytes of the data that we read from the bundle, and we use this to create an instance of our object detector. So this is how we create the object detector. And when we want to run a detection, so we get a sample buffer, and the first thing that we do, and this is this code, we are taking the sample buffer and we are converting it to an OpenCV image, to an OpenCV matrix. So we just take a reference to the pixel, to the byte array of the image pixels, and using the pixels, we just create an instance of a matrix. Okay, so this is how we convert a sample buffer, an image from the camera, to an OpenCV matrix. So this is converting the sample buffer to an OpenCV matrix. And once we have the matrix, we can call the detect method. Here we are making sure that the detector really exists, and we do it only once. Okay, our detector is static, and we have only one instance of this detector. And we run detect on the image, and then we take the result. We just create an array, and we loop through all the detections, and we encode the detections into the array. We assume that each detection has 6 values. Okay, so this is important when we are going to like decode this array into detections. So we assume that each detection has 6 values. So this is our native CV detector, and this is the code that we are going to call from our Swift side of the application. So now that we have the code, it's not enough, obviously, because we need to embed the TensorFlow Lite framework into our application. So in order to do this, we are going to the application setting. In the general tab, here under frameworks, we are going to add, and we add files. And here we are going to our tflite dist, libs, iOS, and select the TensorFlow Lite C framework. And we open it. Okay, we open the framework, not the files inside. And this added the framework here. We have some more settings to do. So we are going to the build settings. And the next thing that we wanted to add, if you remember, is the TensorFlow Lite headers. So it's under under search path, we have the header search path, this one. So I will go again to the TensorFlow Lite dist, include. This is where the headers, where the header files are. So I'm just going to take this path, I'll copy it, and here under header search path, I'll double tap, plus, and I'll add this header here. So this is for the headers. And another important thing that we need to add is the framework search path. When we are linking the application, Xcode is going to search for the framework. And so we need to add our framework folder to the framework search path. So again, under tf-lite dist, I'm going to go to the libs iOS file. This is where our framework is. So I'm going to copy this folder, the path to this folder, copy. And under framework search path, double tap, we already have the OpenCV rules, and I'll add this folder. Okay, so now we have the header file, the header files, and we have the framework. Let's check our object detector. Okay, so I expect this error to go away. Good, it found the header. Let's try to build the project. So build. We got an instant failure. Building for iOS, but the linked and embedded framework, TensorFlow Lite C framework, was built for iOS and iOS simulator. Okay, so again, I'm not an iOS developer, but from what I understood, you cannot include a framework that contains binary or library for two architectures. So this TensorFlow Lite C framework contains actually the 64-bit version, a 64-bit version and a 32-bit version for the simulator, and Xcode doesn't like it. So what we can do is we go again to our application settings. In the build settings, there is a validate workspace. So we are going to change this validate workspace to yes. And this is going to let our project to build, but apparently this is not enough. So if we go to our build phases here, and there is this blog post about dynamic libraries. So strip out the iPhone simulator target. So what this script is basically doing is looping through all the frameworks that embedded in the application and remove the unused architectures. So when we are going to build for the device, for a 64-bit device, it's going to remove the 32-bit version of TensorFlow Lite C. So this script, as it says here at the bottom, this script is generic, so it will just work as is. So I'm going to copy this script. And here in build phases, there is this hidden plus button. We're going to do a new run script phase. So this is the run script phase, and we're just going to paste it here. Okay, so now we have this script, and let's again try to build our project. So once again, I'm not an iOS developer. If you know a better way to fix this error of having two architectures in the TensorFlow Lite C framework, please feel free to comment. Okay, still got one error. Phase script execution failed with a non-zero exit. Okay, command. Okay, what I could forget is here, let's go back to our application settings in the embed framework. So we are embedding our TensorFlow Lite C framework. We want to copy this framework. So I think this was the issue. The script didn't find the framework. So again, product, build, and build succeeded. Okay, so the build succeeded, it means that our object detector code that we wrote once is compiled successfully on iOS. This is good. Now let's go to our object detection view controller, and let's actually use the code. So again, we are going to create an instance of our CV object, and the CV object is this one. Okay, so this is the code that we are using. This is the bridge code between our application and the object detector. We are not using the object detector directly. We have some bridge code. This is like in Android, we had the native lib, the JNI code. So this is like the same. So we are creating an instance of our CV object. And in the capture output, we are going to process the camera frames. So I'm just measuring the time. So how long it takes to process frames. So this is what I print here. And that's it. We are calling to our CV detect method, and we give it the sample buffer. And once we get the detections, so here we are, the detection, if you remember, it's an array of NS numbers. So we just convert the numbers to float, and we give this detections array to our detection canvas. And then on the main UI thread, this is important, we want to mark our detection canvas as dirty. So the OS is going to re-render our canvas. So we call to set need display. And again, it's important to do it on the main UI thread. And once we call the set needs display, sometime in the very near future, the application, the OS is going to call our draw method of the detection canvas. And again, we assume that each detection has 6 numbers. So this is how we get the number of detections. And we just iterate through all the detections, and we draw the rectangle, and we print the label of the detection. The label, again, the labels themselves are embedded. The label file is embedded in our application. So in our object detection view controller, we just get a reference to the text file and read the content of this text file and split it by a new line and give this array to the detection canvas as label map. And here we just take the label index that we got from the detection, the class ID, and we take the description. This is it. Again, let's build our project, and let's run our application and see what happens. So I'm going to share my my iPhone device using a QuickTime. So I'll be back when it's running. Okay, so here is our app. Let's open the object detection view controller, give permissions, and here we get the detections: keyboard, cell phone, mouse. The screen was TV, if I remember correctly, which makes sense. Okay, so this is our object detector running on iOS as well. And you can see here that the detection time is like 600 milliseconds per inference, single detection. It's not bad. And That's it.
Okay, so this concludes our video series about cross-platform object detection using TensorFlow Lite C API. And back to the beginning, let's just wrap up what we did. So we started by converting an object detection model from TensorFlow to TensorFlow Lite, and then we developed our object detector in C++, and the object detector is using the TensorFlow Lite C API. And then we built applications in Windows, Android, and iOS, all using our object detector in C++ to run object detection. That's it. I hope you will find it useful. Thank you. Bye bye.